We are taking question and answers on C++. What are class and object in C++? In C++, as we know, it is object-oriented programming language. That is why we have the concept of object. In any programming language, which is OOPS or object-oriented programming language, there will be a class and all will be based on objects. Let me show you the class. This is a class. Basically, class is a keyword, and this is a framework. You can say it is a blueprint. So class is a user-defined data type, and that has data members and member functions. Why we are calling it as user-defined? Because we are making it. So we have the data members and member functions of this user-defined data type. So the data members are also called as the data variables, and these are the data variables I'm pointing, and then we have the member functions. These are the functions that are used to perform operation on these variables. So the object is what? There will be an instance of this class. That is, the data variables and the functions, they are part of a class. They are inside a class. They are encapsulated in a class. So this capsule is a blueprint, is an entity which is a single unit, you can say. Okay, and that single unit is represented by an object. So when you say A obj, we are making an object of this class A. So all the content, all the unit, we are naming this unit as one, and that one is obj, object. Obj.data, it can access obj. If you have some pointer, you can use arrow. So this is how we call, access the data also and the function also. So if you just think that this whole data and function are in your fist, and you close that fist, that is called a blueprint, and that is a main say document, and you can make multiple photocopies of that document, and that multiple photocopies are nothing but objects. Okay, please remember, class is a user-defined data type, and object is a variable of this data type. Object is a variable of because like int a you write. So a is an integer variable. Similarly, an object is a, see, I'm just showing here. If you're saying int data, data is an integer variable. Similarly, an object is a variable of a class. So let me show you here that you have a class called car. Now we can have multiple objects, say multiple different cars can represent this class. It can be Toyota, it can be Ford, it can be Volkswagen. Okay, so this is object 1, this is object 2, this is your object 3. So there are innumerable objects you can create. There is no limit, only your resource memory, that is only the limit. Otherwise you can make any number of objects you want when you make a class. Okay, I hope you got the idea. Class car that have properties like name, color, etc. They have the methods also, like they can have same function, speed, and they will have speed, but they different objects, we will make it differently. What is inheritance? Inheritance means, here let me give you a real life example. Your father, his father, and you yourself. So your father might have got something from your father, means his father, and you have got something from your father, that is, he is your father and you are his son. So you might be getting some belongings, some property, some money, or well, say good wishes, you can say. So you are inheriting that kind of thing. So you don't have to work for that amount or that property which he has already given you. But if you want to earn more, that is up to your prerogative, right? So your father is your base class, and you are a derived class here. For example, your father and his father, your grandfather. Your grandfather is the base class for your father, who is the say child class for your grandfather. Let me show it here. This is the animal base class. Animal can eat, animal can sleep. Every animal does that. Then you have a dog. So you have made a class which is derived from animal, and eat and sleep has already come here with a dog. But there is one more function you have added, that is called bark. So reusability has increased, and dog is having now 3 functions: eat, sleep, and bark. So this is the use and this is the benefit of inheritance. So inheritance is an object-oriented paradigm, says support or a very important aspect factor. This is the mechanism in which you can create a new class which is called as a child class or a derived class from the existing class which is called a parent class. This child class is also known as a derived class. Parent is also known as base class. See, the child is inheriting all the content of base, but base cannot inherit anything from the child. The reverse is not possible. So dog extends animal. Dog class, it extends animal. That is, the dog is inheriting the animal class. You can say animal is inherited. So it allows us to, that is, inheritance is allowing us to create a new class which is the derived class from the existing class, which is the base class. It is reusability. The derived class inherits the future from the features and the, say, data members and the functions which are public and protected from the base class, and can have additional features of its own, which you see here in the dog class, which is bar, additional feature. Okay. Now this is the base class. We have a print function. Then you made a derived class which is inheriting base. Okay. So both the functions are same here. This is also, I'm giving you an example of overriding and this, because it is not always that the function of the base class because already this is there with you, but you can write your own code for the same function also. Okay, so I'm just giving an example of function overriding. How do you make it? So you have to make, if you have to really call the derived class function print, then you have to make the base class print function as virtual. What is encapsulation in C++? In object-oriented paradigm or object-oriented programming, encapsulation is a basic, say, building block. So let me show you here with an example. Now we have a class called rectangle. We have 2 variables. We are calling it as variables. Then length and width. Then we have a function. We are calling it as methods. Methods, operation, procedure, number of names we call. So a class is having some data members or values, and we have function. So this class is actually encapsulating these 3 things: 2 data values, 2 data members, and a function which is operating on these data members. So it is kind of inside a capsule. So inside this capsule we have, these are the variables, and then we have methods. This is a function. There can be multiple functions. There can be multiple data values or variables. So braces are actually capsule. So encapsulation is the process of wrapping together the data and the function that use them in a single unit. Since it bundles, it encapsulates the related data and function together. This makes the code cleaner and easy to understand. So when you make an object of this rectangle, obj object, because this class is just a blueprint, and you have to create an object to actually access and work on these data members or variables and functions, which is we are calling as methods. So there are 3 types of encapsulation: member variable encapsulation, function encapsulation, and class encapsulation. Member variable encapsulation means all the data members are declared as private. This is member variable encapsulation. Function encapsulation, some member functions are declared as private, and class encapsulation means all the class the class is itself declared as private. Define abstraction in C++. So abstraction is all about showing the details or hiding the details. How much details you want to be shown to the user or end user. Now here is your television. Now we have control, right? We can switch it on, switch it off. We can increase the volume. We can change the channel. We just do it by click of button on the remote control. But what are the internal process? What are the programming done? What is the hardware inside? Are you aware of this? No, and you don't need to be, because the internal details is not relevant for you. It should be hidden because you don't need it. I am not saying that it should not be open for you, but it is not desired by you. Why would a car owner know everything about a car part? So an abstraction in C++. Previously in the structural programming, everything was open. So abstraction in C++ is a technique of displaying only the essential information and hiding the internal implementation and the background details from the user. Why we should show when the user doesn't want it or he is not interested in it. So implementation, we have it can be done in two ways. Data abstraction in C++. You can do it using the class and access specifier. I'll just give an example. And header files implementation. So you can also make an abstract class. That is also possible. Okay, there are multiple ways. So int a is by default in C++, it's private. But let us say we are making it as private. So integer a we have defined inside a class and we made it as private. So now when you made it private, it is not accessible from outside. It is inside the class, so it is the internal detail of the class which shouldn't be known to the outside users. So you just make an object and work with that object. How this function is written, how the variables are there, why you need to know that? You just need to add two numbers, give two numbers and get the result. How that addition function is implemented, what variable it is taking, you don't need it. There is one more way of doing it. You make an abstract class. So when you make an abstract class, whatever functions we give here, we are not giving the implementation of the function. So we are just giving in an abstract class. Normally what we do, we don't give the definition of any function. It is the duty of the object, the class which inherit this class, that will implement the function code, that will write the function code. This is abstract classes. So there are a number of ways in which the abstraction can be achieved. Few of these I am giving. Let us take this example. This is an abstraction example. You have made these two variables, which one is integer, one is character, as private. So now you have given an abstraction here. Similarly, you can also do it with this function also. So this function is accessing the private members. So these private members are only accessible to this function only, not outside. It is not available outside. Means you just have to, whenever you're using this function through the object, you are not interested in integer, character, num, ch, right? So that is a kind of abstraction we have provided using the access specifier or access modifier. This private is all about the access specifier or access modifier. Difference between C, C++, Java and Python. So these are the most popular, widely used programming language. Let us see one by one. First is C is a procedure-oriented programming. Procedure means function. That is, a main function is going to call another function, and these function in turn will call another function. So this is called a procedure-oriented or structural programming. Then we C++, Java, they both are object-oriented programming, but Python is both. It is procedure-oriented programming language also, an object-oriented programming language also. Python is both of them. Then, who developed it? C was developed by Dennis Ritchie. C++, Janne Stroustrup. You can call it as Bajane also, but Janne Stroustrup is how it is being spoken. Java is by James Goslings, and then Python is by Guido van Rossum. What is the level of this language? C is the middle level language, very close to hardware. C++, Java and Python, they are high level languages. High level language is more like an English language. Okay, it's like what you want to type. Then we have middle level language, then we have the assembly language, then we have the actual machine language. So C is somewhat middle level language. Others are higher level language, that is the English like language. That is why you are able to write so easily. What are the building blocks? In C, everything is function. C++ and Java. C++ is object driven. Java is object and class driven. Basically, both are object and class driven. You have to make a class and you have to make an object. But Python, object and class, it is always there. But we have function also, because it is both procedure-oriented programming and object-oriented programming. When you make a program, what will be the extension? C will be .c, C++ .cpp, Java will be .java, and Python will be .py. Platform, C is platform dependent. Once you make the program in C in another configuration, it may work, it may not work. C++, Java, Python, they all are platform independent. You can make the program anywhere and you can port it and run in any other place. That is why Java has come in. It has bytecode. The comment style is the /* write the comment and end it with */. The C++, you can use this also. You can use the double line also, the double slash also, the slants. And then we have Java. It's similar to the C++. In Python, it is hash for single line, and double quotes means for the multi-line comment. How many keywords are there? C has 32 keywords. C++, it has 50 keywords, and Java has 63 keywords, and Python is 33. Dynamic variables, they are not supported in either C, C++, Java, but Python, the dynamic is supported. What does it mean? It means that in C, when you have to x equals to 5, you cannot do. You have to tell the compiler it is int x, then only you can say int x equals 5. Same with C++ Java. But Python, you don't have to give int also. You just say x equals 5. Python will automatically take whatever variable is assigned to it. Data security. C is not very secure because everything is open. Of course, the data is not open. Everything is global and all go-tos are used. The C++, Java, C++ is secure, but Java is more secure. And Python is also secure. Now let us just see a coding difference, how the coding will be done. In C, this is just a hello program. So the C is mostly used to develop system software. So we are using hash include stdio.h, it is the include file. Then we have int main, printf is used to print hello and return 0. Output will be hello. Now coming to C++ program. See, this is stdio.h. Here we are using iostream. You don't need to use .h. Using namespace std, this is used for name collision, avoidance of name collision. Then we have int main. In place of print, we use cout. Okay, C++ is also secured and used to solve many real-time problems. Then we have the Java program. So this main is inside a class. We see here. This is class hello world. Inside this we have PSVM, public static void main. So everything is class in Java. So class hello world, then public static void main. Inside this you have some argument. So this object you will make of class hello world, and then when you actually instantiate, then this main function will be called. String args is an argument and system.out.println. SOP, what we call it as hello. Then we have the Python. See, you don't have to do anything. Java is very secure and robust language. That's why it's very popular than other languages. What about Python? You have nothing to do. Just write print hello. No inclusion, nothing. Python is the future. Pure line of code you have to write. It has various library to solve different types of problem. Image processing, the AI it is being used. What are stack and heap? Stack versus heap. Now you see here, in any program language, you need to know whenever you are making a program, you are taking different variables, declaring various variables, where they are going to stay or being kept in your memory. This is your random access memory. You are starting from low memory, that is 0, you can say, from 0 to some higher number. So stack allows the stacking of local variables, method data and subroutines, one above the other of the function. The stack is all about plates or one over another. So it will be last in first out. So last in first out, yes. See, stack, what are you putting here? Auto variables and parameters. Heap is keeping what? Heap does not stack the data but allocate the memory to each member using the dynamic memory allocation. If you are these heap, all the dynamic will go to heap. That is, when you are using the new operator or the malloc or calloc, it will go in heap. This first area, let me show you one area. This heap, it is the dynamic memory that can grow or shrink as per our need. We also call it as free storage. The size of all other segment is decided at the compile time, but heap can grow during runtime. So we can control memory allocation and deallocation in heap space. So dynamic allocation, heap. Now coming to stack, it is the space where the local variables are placed. The variables which are declared with functions live in stack. Okay, the local variable, if you have function inside that you have variable, it will go in stack, which is the space where the local variables get space. So this is the stack. So first we have heap, then we have stack, then we have the place for static or global. So a space to store all the global variables. So variables that are declared outside the function and accessible to all the functions are placed here in this area, which is below the stack. Right? All the functions outside the function. Inside the function, they will be kept in stack. Auto variable kept in stack. And the below one is the actual compile instruction, you can say, the text. You store all the instruction in the program. This is the area. The instructions are compile instruction in machine language. What are templates in C++? What is template? See, so if you want to write a document, for example, you have to write an SRS or a SDD. So or your project. So your professor will give you a template. Okay, this is a template. All of you write in this template. It will give you an idea. Now you can fill in the headings, the formation, everything will be given by the template. Same way, in C++ we have templates. So templates in C++ is a blueprint to create a generic class or even a function. So this template is used to pass data types as parameters. So you don't even write the data types even. They are also parameters. So using template, we can create single function or a single class which can work with different data types. That is why we are calling it as a blueprint. I'll give you an example. Before that, it's coming from the STL. This STL is standing for Standard Template Library. This is a library of container templates that provide generic classes and functions. So STL components, what are they? They are containers, algorithms, iterators, and function objects. So this is the example. I'll just show you how it works. But before that, there are two types of templates in C++. As I said, we can create generic class or a function, That is why it is function template and class template. There are two types of templates. So see the example here. What we have done here is we hash into hash stream, then we have template, and then we have a type name which is capital T. Nothing else, only T. Then this T, add T num1, then T num2, return num1 plus n num2. So the return type, that is, you put in place of T integer, I am replacing T with float. So it's up to me and you. So this is what you have done. What you have done? See, I'm going to call this function, and now I am giving integer. So this function will be transformed whenever we give add and the angle brackets int 2 comma 3. All this T, capital T, will be replaced by integer. So it will be this function. Similarly, when I'll do it, I'm giving it as double now or float. So add double, then two values 2.2 and 3.3. All this T will be replaced by double. Everywhere double will be replaced. That is how the generic will be converted into actual when you actually run and give the proper data type. This is a template, and it is worth, because it is just a blueprint, can be used wherever you want and whenever you want. What is call by value and call by reference in C++? So main thing is, let us start with an example. You have a main function. Then there is a function I am calling. Say fun is the function name. Now I want to give 2, 3, and I am saying, okay, swap the values, or add the value, or increment values. So inside that function it will become 3, 4. So when I come back and then I print this 2, 3, 4, it will be 2, 3 only. What I'm saying is, when I'm calling it as value, it will be 2, 3. But when I'm calling it as a reference, so when I'll print this 2 and 3, it will be 3 and 4 in our main. So that is the calling by reference. So the call by value, actual values are not changed. They are only copied. Call by reference, actual values are changed because you are passing the reference. Reference is all about you are indicating, aliasing, giving an alias to that particular area. So what we are doing here, we are giving n1 and n2. These are two variables. We are sending it to a function called swap. So I'm sending 2. Let us say it is 10 and 20. I am inputting 10 and 20. Then I am sending in swap 10 and 20. So how are we writing swap? We are writing it in call by value terms. So when we are saying call by value, swap 10, 20 will be called. So 10 here it will be, 20 here it will be. So what will happen? So there will be just a copy of 10 and 20 will be made. So you just copy has gone. So this is 10, this is 20, and now when we gave 10 and 20, it has made its own location 10 and 20. Right? Now when we swap it, 20 and 10 will be swapped. No doubt they will be swapped. But it will be swapped in the location which this swap function has decided. Right? So when you print this inside your main, it will only be 10 and 20. It will not be swapped. You wanted to get it swapped, but it will not be swapped. Right? But you wanted 20 and 10. What to do with this? Because you have just sent the copies of the value. You have not sent the actual location of the value or the memory location of the value. So you need to do something else. For that, we will use call by reference. Most of the time, we don't want call by reference because we don't want to change the values. We are just using functions to get our work done. So call by value, duplicate copy of original parameters is passed. there will be no effect on the original parameter after the modifying parameter or any function is modifying the parameter. Right now I can give you the example of call by reference. So same thing we are doing with a twist. See, n1, n2, same thing we are inputting, and then we are passing the ampersand. Ampersand is for reference. Reference, this is a reference. So this, wherever these values are there which we are giving, we are actually giving the reference that this is the location of these two values. Do something with these two, but the location is this one. So there will be no copy being made. So you are passing the actual value reference. So you will take it in pointer. You will actually change the positions. So there will be, when we send 10 and 20. So 10 and 20 you are sending here. There will be no copying. You are actually sending the reference. So actually you are sending the address value, the pointer. Ampersand n1, ampersand n2. So this is, you have now ampersand n1, ampersand n2. Now whenever swapping is done, 10, 20 will come here, 10 will come here. So the memory location remains the same. There is no copying. So actually you are getting 20 here and 10 here. So even if you put inside this function, if you print, you will get 20 and 10. When you come outside, inside the main also, when you print, it will be 20, 10. Right? So this is the reference. Okay, call by value is all about copying. That is, you are just copying the numbers. There will be another memory location being made, and then swapping will be done. But here you are actual call by reference, actual copy of the original parameter will be passed, and original parameter gets affected if the value of the parameter change inside function. What is an inline function? So the name is itself saying the inline function. That is, whenever the function will be called, it will not, the control will not pass. That function will be embedded. The lines will be embedded here. Right? Inline function, when called, expands inline. That is, whenever you call this function, the whole code of the inline function will get inserted, will get substituted, will get embedded at the inline function call. So inline keyword you have to use here. But before that, let me just show you, this is a normal function. When you are calling a normal function, the control will go to the function being called, and the control will pass on through that function, and finally that control will come back again to the main function. Okay? In inline, this will not happen. The whole value, the whole instructions will be transferred inside your main body. They will get inserted. They will get substituted. For example, in the function you have written print. So in inline, this print code or this print instruction will be embedded inside your main. So as I was telling you, this control will go in normal function, control will come back. Here you will call the inline, and those inline lines of that inside the function will be embedded. So you have to use the inline function, inline keyword. This will make the function to be expanded inline rather than being called as a normal function. Inline is just a request to the compiler. It is not a command. So compiler may also ignore it. So in order to create an inline function, just precede the function or write before the function name inline. You have to declare the function with the keyword inline. Right? You have to write inline here if you want to make this function as inline. You don't want to make it as a normal function. So it will, in various ways, this inline function helps. Inline function and macro differences. What are the differences between two? See, both are almost same, but the working is different. See, inline is, let me tell you the difference one by one. Inline, these are the functions provided by C++, by the language. And macros, in any function, once you write inline in the front, it will be inline. Macros are preprocessor directives. Before even the processing will commence, macro are preprocessor directives, right? Before the execution, before anything can happen, the pre-processing activity macros will be handled. Okay. Now let me give you an example. So normal function, what will happen? Whenever we call it, the control will go to the function, actual control, and the result will be sent back to your main function. So when I make it as inline, what will happen? This whole code, that line, the instructions will be embedded, will be inserted here, substituted here. Okay. Now in macro, same things happen. The line, whatever you have written, declared as macro, that line will be embedded or substituted. Let us see here. We have a hash defined. This is just a variable, but the second line is hash defined cube x, x into x into x. So these hash defined is saying these are preprocessor directives. So whenever you call it, if you just give cube 2, so it will be converted to 2 into 2 into 2. So whenever you say cube value, here 2 into 2 into 2, x into x into x will be replaced. That is same work, you know. So inline keyword is used to declare the function as inline, and for macro we use hash define. So hash define for macro, inline for the inline keyword for inline function. Inline function can be defined inside or outside the class, but macro cannot be declared inside the class because this is a preprocessor directive. You never say hash defined inside your class. So before even anything can happen, this is a preprocessor directive. Inline functions are parsed by compiler, but macros are expanded by the C++ preprocessor. So before compiler there is a preprocessor. C++ preprocessor will work on macro and the compiler will work on inline function. Inline function is just a normal function. It can access the data member of the class. For example, you have a function, you have some, say, print. Say any code you can take. This I'm giving us of C. So you say hi. This will work as a normal function. You make it as inline. So whenever you call this function, this print hi will be embedded here. It's just a normal function. It can access the data members of the class. Macros, they cannot access the data member of the class. They cannot access. Inline function, compiler replaces the function call with the function code, as I was suggesting. So C processor, say C or C++ preprocessor, replaces every occurrence of macro template with the corresponding definition. Okay. And inline function, they follow strict parameter type checking, but macros does not follow strict this parameter type checking. Okay. Inline functions may or may not be expanded by the compiler because it is a request. Inline is a request. It is not a command. So the compiler can accept the request. It can deny also. But macros will always be expanded because it is preprocessor. It will always be done. Inline can be used for debugging a program. Macro cannot be used for debugging as they are expanded at pre-compile time. Okay. The function will be written like this. I already told you. You just have to precede it with inline keyword. Here you have to do hash define sum a b, and then a plus b is the instruction which is to be executed whenever sum a comma b will be called. There is one more thing. See, plus plus I prefix and all these kind of operators. You have to use inline, not macro. Okay, this is all about this discussion. Thank you so much. Take care of yourself.